Today, Connor and I will be teaching you how to do number 6 in your chemistry packet. And the first thing we want to do is set up our chemical equation. So we have our sodium carbonate and our hydrofluoric acid on the left of the equation. And they produce sodium fluoride, carbon dioxide, and water. So the first thing we want to do in this situation is balance the chemical equation. So we see that there are two hydrogens on the right side, so we want to put a 2 in front of the hydrofluoric acid. And then we see that there are two sodiums on the left side, so we want to put a 2 in front of that sodium fluoride. And so the first thing on our agenda is, what kind of reaction is this? So we see that this is a double replacement with decomposition. But just to put it into a little bit of simpler terms, we're just going to label it as a replacement equation or reaction. The next step we want to take is answering part B, which is if 3.5 moles of hydrofluoric acid react with 76.5 grams of sodium carbonate, how many moles of sodium fluoride is produced? So first we want to convert the 76.5 grams of sodium carbonate into moles. And what we want to do is put on top 1 mole and on the bottom the molar mass, which is 105.97 grams. So that comes out to equal 0.7219 moles of sodium carbonate. And so right now what we've just done is figured out that sodium carbonate is our limiting reagent in this equation, because we have 3.5 moles of HF, which is the hydrofluoric acid, and 0.7219 moles of the sodium carbonate. And the 3.5 moles is obviously much larger than the 0.7219 moles of sodium carbonate. Now that we have found our limiting reagent, we want to take that 0.7219 moles of sodium carbonate and multiply it by the mole-to-mole ratio from sodium carbonate to sodium fluoride, which is a 1:2 ratio. And that should produce 1.4438 moles of sodium fluoride. The last thing we have to do for this question is answer part C, which is, what is the mass of the excess reactant that did not react? So we want to take our 1.4438 moles of sodium fluoride and multiply it by the mole-to-mole ratio of sodium fluoride to hydrofluoric acid, which is a 2:2 ratio, and which should just give us 1.4438 moles of hydrofluoric acid. Now that we know how many moles of hydrofluoric acid we have, we want to take that initial amount of hydrofluoric acid and subtract it from the actual amount of hydrofluoric acid that was used. which is 3.5 moles of hydrofluoric acid minus 1.4438 moles of hydrofluoric acid. And after we should subtract, we should get 2.056 moles of hydrofluoric acid. And now that we have the difference, we want to convert that 2.056 moles of hydrofluoric acid into grams by multiplying by the molar mass, which is 20.01, over the 1 mole, which should produce 41.14 grams of hydrofluoric acid. So just to recap, the first thing we did for this equation, or this problem, is we figured out what kind of reaction it was, and we realized that it was a replacement problem. The second question that we answered, part B, which was if 3.5 moles of hydrofluoric acid react with 76.5 grams of sodium carbonate, how many moles of sodium fluoride is produced? We figured out that 1.4438 moles of sodium fluoride will be produced. And lastly, we answered part C, which is what is the mass of the excess reactant that did not react? And we figured out that 41.14 grams of hydrofluoric acid will remain. Thanks for watching.